What?
I put this for my homework class.
For last night's?
Yeah.
I'll take it. Okay, is anybody else using a homework pass on last night's homework? I'm going to come around and look at it in just a second. Okay, first thing we're going to do is go over the last two problems on the weekly worksheet. And some of you, I didn't mark it wrong and yours was wrong on number 7. So everybody flip your last week's weekly worksheet to number 7. Okay, it said find the prime factorization of 24. And I gave you a note to remind you that you use a factor tree. This is not listing the factors. If it wanted you to list the factors, it would have said list the factors of 24. That would be where you do 1 and 24, 2 and 12, 3 and 8. That's listing the factors. Prime factorization is where we get it all the way down to its prime numbers. And we use the prime factorization tree. So we start by branching it off. Some of you started it right, but then you did that. Parker, what's 12 times 12?
144.
144. And most people who wrote it like that, and they even wrote 12 times 12, can tell me that that's 144. Okay? What should those two numbers multiply to equal, Maya? Oh, yeah, they should equal 24. So she said we could do 12 times 2. Is there anything else we could do there? Sadie?
I did 6 times 4.
6 times 4 works. Anything else? Parker?
8 times 3.
8 times 3. We could have started all of those ways. And I'm actually going to work this one problem 3 different ways at the same time. Oops. Okay, what do I do next if I'm trying to get to the prime factorization? Kendall?
You break them down if they can multiply?
Yeah, I break them down until they are prime numbers. Maya, give me 2 numbers that multiply to get 12. 6 times 2. What do I do with that 2?
Just bring it down.
Just drop it down. Some of you guys left them hanging up at the top. Finley, can I break any of those other numbers down?
6.
Okay, what can I break it into? 3 times 2. I'm going to drop this, drop this. So all of my work is done. Now I have to give my answer. How do I write my answer? Abby?
2 times 2 times 2 times 3.
Okay, I write them in order from least to greatest. How can I write my answer using exponents? Dane?
2 to the 3rd power times 3.
Yeah, 2 to the 3rd power times 3. Okay, and to show you it does not matter which numbers we start with, I'm going to break this one down. 3 times 2. 4 is 2 times 2. Did we still get 3 2s and 1 3?
Yeah.
Yes. Next one, 8 times, can I break into 4 times 2? The 3 is already prime. Did we get the same answer? Yes. Okay, on your loose leaf, your weekly review loose leaf, I want you to find the prime factorization of 60 and 36. Okay, I want you on your weekly worksheet loose leaf that you already have stapled to it to find the prime factorization of 60 and 36. Brody, can you help me get started with 60? What do I do? What are 2 numbers that I can multiply together to get 60? It ends in a 0, so what has to go into it? What? 5 does higher, even easier. Make it easier. 10. 10 times what? 10 times 6. Abby, are either of those numbers prime? Nope. So let's break them down some more. What can I break 10 into?
5 times 2.
Okay, 5 times 2. What can I break 6 into?
2 times 3.
2 times 3. Brant, can I break any of those numbers down even more? Okay, so I'm done with my work. How do I write my answer? Okay, I'm first just going to write them like that. Okay. Good job. So in order from least to greatest, and he noticed that I have 2, so he's writing 2 to the second power times 3 times 5. Okay, Lori, help me with the next one.
You can do 6 times 6.
Okay, 6 times 6. Bryson, can I break those down anymore?
Yeah.
Okay, how?
Times 2 each.
3, both of them can be 3 times 2. Okay, Bryce, how do I write my final answer? That's all of my work.
Second power times 3 to the second power.
Okay, so you went all the way because I have 2 2's, so 2 to the second power, and I have 2 3's, so 3 to the second power. Okay, last question was, what was it, 3/4 plus 1/4? And this was a review from last year. We're getting to fractions probably in 2 weeks. 3/4 plus 4/4. Oh, yeah. Three-fourths plus 1/4. What is my rule for adding or subtracting fractions? Brady.
When you add, like,
Brody.
don't add the bottom number.
Okay, we just add the numerators. What has to be true about the bottom number? They have to be the same. You have to have a common denominator. And I gave you one that already had a common denominator. So yeah, you just had to add the top. What's 3 plus 1? 4. And the denominator stays the same. Now, if you had that, I gave it to you. But what's the best answer, Harper? 1. Anything over itself equals 1. And again, when we get to fractions, I'm going to get a lot stricter on simplifying them. Let's, on our loose leaf, do one harder problem together. Just to refresh your memory from last year. Let's do 3/8 plus 5/6. 3/8 plus 5/6. Can I add those two fractions? Not yet, okay? We can, we just have to do a little bit of work with them first. What has to be the same? Right there, thank you. What has to be the same for us to be able to add those two fractions, Sadie? The denominator has to be the same, okay? And just like we talked yesterday, no one in here is a magician, okay? We can't just poof, make them the same. We have to use math to get them to be the same. So think of your multiples of 8. Count by 8 in your head. Count by 6 in your head. It doesn't have to be the least common multiple, the first one that they both have. It just has to be something they both go into. Who can think of a number that 8 and 6 both go into? Jude? 24. Could we also use 48? Yeah, if you can't think of anything else, you can always multiply them together to get a common denominator. Okay, Jude said 24. Do they both go into 24? Yeah, so let's go with that one. So I'm going to show it right here. I need that to be a 24, and I need this to be a 24. Now I have to use math to make that happen. How do I turn an 8 into a 24 using math? Parker?
3 times 8.
3 times 8. With fractions, to create an equivalent fraction, if you do something to the bottom, you also have to do it to the top. So what's 3 times 3? 9. So 3/8 is equivalent to 9/24. Okay, on the other side, Finley, how do I turn a 6 into a 24? Times 4. I'm going to do times 4. If I multiply the bottom by 4, I have to multiply the top. 5 times 4 is? How do we add fractions? Just the numerators. What's 20 plus 9?
29.
Is my denominator 48?
No.
What is my denominator?
24.
24. Ooh, how do I change that to a mixed number? Because right now it's an improper fraction. Sadie.
You divide it?
Divide. And guys, we're dividing and writing our answer as a fraction. It's the same thing. The numerator goes underneath the box. How many times does 24 go into 29? Once. Instead of writing 1 remainder 5, we write 1 and 5/24. That's the same thing as writing the answer as a fraction. It's just you don't notice it because it's an easier problem. So all of that would equal 1 and 5/24. Again, you don't have to know all of that right now, but we're getting there. But that should be a review, correct? All of that is a review from last year. Okay, now we've gone over all of that weekly worksheet. I will be passing out next week's in a little bit, okay? But it looks similar to last week's. Okay, last night's homework. As you were working, what questions or what kind of stumped you? What did you get to and you're like, I don't know about this? What did you have trouble with? Or even specific problems? Nothing? You guys got them all right? You had no questions? There weren't any weird things that happened? Nothing? Okay, we'll see. I'm going to give you the answers, and then we'll decide if you have questions. Number 4. 2.31. Number 5. 155. Number 7. 95.55. Number 8. 36. Number 9. 4.5. Oh wait, not number 9, number 10. Number 10, 565.2. If you're just off by a decimal point, are you wrong? Yes. Because is that decimal place important? Yeah, because on this last one, if I owed you $565, I'm like, here's 56. I just moved the decimal point. Would you be a little upset? Yeah, because it's not the same thing. It's an easy fix if you can figure out how to fix it. So if you're off by just a decimal point, and you can't figure out why. If you messed up on your decimal point on like 2 or 3 of them, that probably means you're missing something. There's something you are not understanding, and I need you to raise your hand and ask for help, okay? If it was just on one of them, double check and make sure you moved your decimal place correctly in the problem. One thing I noticed when you guys were asking for help is that on, I think it was number 5. Number 5 was written like this. Nope, 18.6. I saw several people write that problem down. That is wrong. Why is that wrong? Abby?
Because you have to put the
Dividend.
dividend on
Yeah.
the other side.
The dividend goes first, divided by the divisor. Here's why it's wrong. One, it's completely flipped. They are reciprocals of each other, which is a word you're going to learn, okay? They're that would be like saying 2/3 and 3/2. If the
You said you might know how to fix that. Do you know how to get that smaller? I opened my Chromebook and it went straight to that.
oh, pretty picture. What's your stuff?
Rockers for me. And then this 2-foot line.
Okay, so again, if you flip those, you will always get the wrong answer. Okay, it's not even close. That's why we've been stressing the dividend goes in the front, the divisor goes in the back. So if you missed some, that's probably part of it. Really, to do these, we just have to keep practicing. Okay? So that's what we're going to do today. If you missed some, I want you to rework those first. You already know the correct answer. If you did not miss any, find some open space on your paper. We're going to keep working. We're going to start with a harder problem. Okay, so if you missed some, you're reworking first. If you didn't, you're working with me. Bryce, do you have paper where you have room to write?
So can I just read while I'm writing?
No, we're working. You're working. This is new problems. Okay, so we are going to do 126.45 divided by 0.25. Okay, what makes this problem a little bit harder, Harper?
You're dividing by 25.
Yeah, you're dividing by 25, so you have a larger divisor. Have we divided by large numbers before? Yes, we don't love it because we have to do lots of algorithm out to the side. I picked an easier number to work with. Why should we all be able to count by 25s? Quarters, okay? You like money. 25 is a quarter. First, I have to get my problem set up. Abby, what do I need to do?
Go to the 25
Okay?
and like the decimal point go 2 times.
Okay, I have to move it.
That's how many are in.
Okay, so I have to change it to divided by 25. Kendall, what else?
You move the decimal point
2 times in the dividend. So that is 126.45. My decimal point's right there. I may or may not need it. So Caden, you're either reworking last night's or you have a piece of paper out and you're copying these down. Now we set it up. Oh shoot, I'm writing with the wrong one. Bryson, what goes where?
The 12645 goes under the line, and the 25 goes left of it.
Okay, goes out here to the side. Now we start our division. Nate, does 25 go into 1?
No.
Does 25 go into 12? Does 25 go into 126? Okay, and think, how many quarters do you have in $1.26? How many quarters? 5. Okay, so Jude, if you have 5 quarters, how much money do you have? Yeah, 125. So I subtract, I get 1, I drop my 4. Dominic, how many times does 25 go into 14? 0, so I put a 0 at the top. I do a double drop. Remember, if I see a double drop in my problem, that means I have a 0 up in my answer. Again, thinking money, Max. How many quarters can you get into $1.45 or 145 cents? Here, let's just count by quarters. What's the first one? 25, 50, 75, 100. Let's keep going. 125, 150. Do we have 150? Nope, we only have 145. So what do we need? Yep, so we need 5. I'm going to put a 5 up there. It's 125. Is my answer 505 remainder 20?
No.
Is my answer 505 and 20 25ths? No, because you're working with decimals. If you have a decimal problem, they want a decimal answer. Not that those other ones are wrong, but if they give you a decimal problem, they want a decimal answer. If they give you a whole number problem and just say solve it, you get to decide, do you want to give it as a decimal or a fraction, unless they say give your answer as a fraction or give your answer as a decimal. But in general, if they give you a decimal problem, they want a decimal answer. If they give you a fraction problem, they probably want a fraction answer, unless it's a whole number. So, what do I do now? Maya?
Put a decimal point behind the bottom card.
Okay. And yeah, there was a decimal point there. I just left it off because I didn't think I would need it.
And add a 0.
Okay, I add a 0. What else do I have to do with my decimal point?
Move it up.
Also have to move it up to my answer. Now I have another 0 to drop. We should like that one a little bit better. Sadie, if you have $2, how many quarters do you have? 8. How many? 8. Okay, I thought you said 80. So 8 times 25 is 200. We have nothing left over. So 126.45 divided by 0.25 is 505.8. Does anybody know, can anybody relate that and this answer to money? Kind of put it in a word problem? Brady?
Like a word problem?
Yeah. Or tell me, relate that to money. Whatever you were going to say.
It'd be around like $505.80.
Nope. Nate?
$505.
Well, we're not talking about this as a money value, this problem relating it to money. If we're saying this is a quarter, what can we say about those other two numbers? Harper? And again, I'm trying to teach you to think about these problems because decimals don't make sense in our brain. I'm trying to get you to relate them to something that makes sense to you. Money and food make sense to kids. So I try and relate as much as I can to money and food. Word problem. Sophie has $126.45. How many quarters would that be? 505 quarters and then a chunk of another quarter. Can we break quarters into chunks? No, so it's not a realistic word problem. But that's what this is saying, okay? You have 126 whole somethings and 45 hundredths of it, and you're dividing it into chunks of a fourth or 0.25, or like dollars into quarters, a fourth of a dollar. And you would have 505 of those smaller pieces if you divide them up. Brady?
I think it'd be more sense if it was
but it's hard to have 45 hundredths of something. Okay, let's do another hard one. Oh, let me clear this off. Let's do and again, when these don't make sense, let's use mental math, estimating, to get what our answer should be close to. Because this is a hard division problem because there's lots of digits there. What would we round 38.9 to if we had to round it to a whole number? Kendall? 39 or 4, yeah, 39. And looking at the other number, what would we round it to?
30?
Would we round it to 30? What whole number?
1.
0 or 1?
0.
Can we take 38 divided by 0?
No.
Error is what the calculator would tell you. What's 38 divided by 1? 38. So we are going to get something maybe close to 38. How do I get started? Kendall?
You go to your divisor and move it equal point.
Okay, go to our divisor, move it 2 times to get it to the end. So I'm going to be dividing by 32. Go ahead, Kendall.
And then you go to your dividend and move it twice.
Okay, go to our dividend, move it twice. Would this answer be easier to estimate?
Yeah. Yeah.
It would. Okay, let's go ahead and set it up now. 3898 point, oops, I said it right, I wrote it wrong. 3898.2 divided by 32. Move it up into our answer. What do you think I'm going to suggest we do before we really start doing any dividing? Maya? Yeah, come up with a short list of multiples. Do we have to get all the way from 0 to 9?
No.
No, but let's get a good list going that we can build off of if needed. Oh, I don't need that. I keep pulling that up. Let's say times 1 is what?
32.
32. And if you write them like this, sometimes you can just kind of add. What's 32 plus 32? 64 plus 32? 96. And again, if you need to just do algorithm out to the side, that works too. Or repeated addition. Times 4. Because it's plus 2 would be 8. Plus 3 would be what? 128. Let's do one more and then we'll stop for now. Plus 2. What's 8 plus 2? 0. Regroup. 12 plus 3 plus 1. Okay. Let's start. Does 32 go into 3?
No.
Does 32 go into 38? How many times? 1. Remember, I put it above the 8 because I'm going into 38. 8 minus 2 is 6. How high can I go? How many times? Maya? 2 times? Because we already said times 2 is 64. Subtract. Drop. Brant. What next? Just one time, yep. I have 26 left over, which seems like a lot of leftovers, but why am I still on the right track? How do I know that I'm still on the right track, Brody? I mean, that's a lot to have left over, but how do I know it's an okay leftover? Yeah, it's under 32, so I'm good to go. It can be all the way up to 31, and I'm still good to go. It just means my next number is going to be really big to divide into. So now I drop my 2. What do I have to do before I can do this one? Yeah, I have to get my multiples higher because I'm only up to 160. So let's go ahead and do times 6. Where would that get me? 192. I'm getting closer. Let's do another 32. 2 plus 2 is 4. 19 plus 3? 22. Let's try one more because we don't know for sure. It's probably going to be times 7. What's 4 plus 2? 6. 3 plus 22? Do you think we can go one more? No. Probably not. Okay, so let's put our 8 up here. 2, 5, 6. Everything else cancels. Is my answer 121.8 remainder 6? No, it doesn't even make sense to say that. Abby? Yeah, I can add as many zeros, and again, I add them in the problem because I'm not changing the value of that problem. 3898.2 and 3898.20 are the same thing. I'm going to drop. How many can I do, Soph? 32 into 60. Just one. Why do we not like this problem? Yeah, it's a long one. So 5 minus 3 is 2. What do I have to do? Add another 0. Again, how many zeros can I add? As many as I need. Are we high enough yet? No. We do have to go all the way up to 9 on this one. 256 plus 32. So that's an 8. 25 plus 3. Wah, wah. So we have to do 8. Need my pen back. You guys having fun yet? Shh. So 8 is 256. $24 left over. What do I have to do? Add another 0. How many times does 32 go into 240? 6 or 7? 7. 224. I'm going to subtract. Okay, now we have gone out 4 decimal places. I picked this problem for a reason. I made it up. Most of the ones I make up, they're ugly. It's hard to make up decimal problems that have pretty decimal answers. Okay, but in 5th grade, generally you see the pretty ones. Okay, somebody spends a really long time coming up with problems that come out pretty. You just got to do the multiplication. Multiply 2 pretty decimals together, and that gives you your divisor or your dividend. Okay, but rule of thumb, and that's why I picked this one. If it's one of these long ones that you're like, it's never going to end, you go out 4 decimal places. That's a lot of work, okay? We just went out 4 decimal places, so I'm going to write down our answer. I'm going to write that it is about equal to 121.8187. But if I write that, I chopped it, meaning I chopped off that remainder 16. So once we go out 4 decimal places.
But wait, you can add it.
Okay, but you don't have to. That's what I'm saying. Go out 4 decimal places. Once you get 4, you can stop, but you can't chop. How do we give a good answer without just chopping off extra information? Round it. Okay? Stop at 4. Round it to 3. Would that 8 stay an 8 or go on up to a 9? It would go on up to a 9. Okay, and again, that is a 100% perfectly okay answer. In 5th grade, if they give you an ugly one like that, they will tell you round to the 10th place, round to the 100th place. But a general rule, if it doesn't tell you what place, if it's an ugly one, you go out 4 places and then round to the 1000th place. Remember, anytime you're rounding, you have to go out 1 extra place. So if you're rounding to the 10ths, you have to go out 2 places. If you're rounding to the 100ths, you have to go out 3. Okay, all next week we are reviewing decimals. Monday, Tuesday, Wednesday, we're just reviewing dividing decimals because it just takes a lot of practice. There's lots of weird things that pop up on different problems. Thursday and Friday, we are reviewing all of the decimal operations. That following week, we will have a test over add, subtract, multiply, divide decimals. Okay? I'm going to stop here. You don't have any homework, but I am going to pass out next week's weekly worksheet. So if you want to get started on it, you can.